Hello everyone. Today we are going to see about wireless communication. The subject code is EC3501. The fifth unit is wireless networking. Today's topic is traffic routing. So these are the topics in the fifth unit. The third topic is traffic routing in wireless networks. Under this we have to see circuit switching and packet switching. So let's see about the introduction of traffic routing. The amount of traffic capacity required in a wireless network is highly dependent upon the type of traffic carried. Some traffic may have an urgent delivery schedule, while some may have no need to be sent in real time. The type of traffic carried by a network determines the following. The first one is routing service, second one is the protocol, and third one is call handling techniques. So there are two general routing services provided by networks. First one is connection oriented services and second one is connectionless services. The other name for connection oriented service is virtual circuit routing and the other name for connectionless service is datagram services. Let's see about connection oriented routing. In connection oriented routing, there is a communication path between the message source and destination. It is fixed for the entire duration of the message. And the call setup procedure is required to dedicate network resources to both the called party and calling party. Since the path through the network is fixed, the traffic is connection oriented arrives at the receiver in the exact order it was transmitted. This relies heavily on error control coding to provide data protection in case the network connection becomes noisy. If coding is not sufficient to protect the data, the call is broken and the entire message must be retransmitted from the beginning. So the second one is connectionless routing. In this case, it does not establish a fixed connection for the traffic and instead it relies on packet-based transmission. That is, several packets form a message and each individual packet is routed separately. Successive packets in the same message might travel completely different route and encounter widely varying delays throughout the network. So the packets sent using connectionless routing do not arrive in the order of transmission and must be reordered at the receiver. Several packets form a message and each individual packet in a connectionless service is routed separately. Because packets take different routes in the connectionless service, some packets may be lost due to network or link failure. However, others may get through with sufficient redundancy to enable the entire message to be recreated at the receiver. So in the case of connectionless routing, it avoids having to retransmit the entire message but requires more overhead information for each packet. In the connectionless service, a call setup procedure is not required. So we have two types of switching. One is circuit switching and second one is the packet switching. Let's start the circuit switching. In the case of circuit switching, it establishes a dedicated connection between the base station and the mobile and a dedicated phone line between MSC and MSTN for the entire duration of a call. Wireless data networks are not well supported by circuit switching due to their short bursty transmissions, which are often followed by periods of inactivity. So, circuit switching is best suited for dedicated voice only traffic or for instances where data is continuously sent over long periods of time. And the second type is packet switching. The other name for packet switching is virtual switching. It is the most common technique used to implement connectionless services. It allows a large number of data users to remain virtually connected to the same physical channel in the network. It breaks each message into smaller units for transmission and recovery. So when a message is broken into packets, certain amount of control information is added to each packet to provide source and destination identification as well as error recovery provisions. So let's see about the packet data format. Packet consists of header information, user data and a trailer. The figure is shown. Here we have header, user data and trailer. The header, it specifies the beginning of a new packet. It contains source address, destination address, packet sequence number, routing and billing information. Then we have the user data. It contains information protected with error control coding. And trailer, it is the last part of the packet. It contains CRC code, that is cyclic redundancy checksum code, which is used for error detection at the receiver. So this is the structure of the transmitted packet. So in the header we have flag, address field and control field, and then in the user data portion we have the information field, and in the trailer portion we have the frame check sequence field, that is the CRC code for error detection and correction. So let's see the structure of the transmitted packet in detail. It consists of 5 fields. First one is flag bit. It indicates the beginning and end of each packet. And next we have the address field. It contains source and destination address. And the third field is the control field. It defines the functions such as transfer of acknowledgement, ARQ. ARQ is nothing but automatic repeat request, and packet sequencing. And fourth one is the information field, which contains the user data, and the length of the user data may be variable. And last field is the frame check sequence or cyclic redundancy check or CRC. It is used for error detection and correction. And this packet switching is also called as packet radio when used over a wireless link. It provides excellent channel efficiency for bursty data transmissions of short length. The advantage of packet switch data is that the channel is utilized only when sending or receiving burst of information. This benefit is valuable for mobile services where the valuable bandwidth is limited. So this packet radio supports intelligent protocols for data flow control and retransmission, which can provide reliable transfer in degraded channel condition. X.25 is a widely used packet radio protocol that defines a data interface for packet switching. So this is taken from the textbook Wireless Communication by Rappaport. Thank you.